Hello everyone. What we'd like to do in this video is graph transformed versions of exponential functions. So recall that what an exponential function is. An exponential function, I guess what I'll call kind of a basic exponential function. I might call it kind of a parent exponential function or a parent function. But the simplest exponential function is something of the form b to the x. Now there are conditions on b. B has to be greater than 0 and b can't be 1. But what we want to pay attention to when we are transforming these type of graphs is we want to pay attention to where the key features of an exponential function are moving. So what we're always going to want to keep track of, I'll write kind of here the key features. The key features is, well, what points do we know are on b to the x? Well, if you plug in 0, b to the 0, or anything to the 0 power is 1. So you plug in 0, you'll get an output of 1. Or if you plug in 1, b to the first power is just b. You plug in 1, you get an output of b. This will be true for any exponential function of the form b to the x. But another feature that an exponential function has is a horizontal asymptote. And we'll want to keep track of that also. They have a horizontal asymptote, y equals 0. So the x-axis is a horizontal asymptote. They have a horizontal asymptote. Okay, so let's go ahead and do some examples. So I'm going to go ahead and erase this. Okay, so for our first example, is let's say we have the function. Let's say we want to graph f of x, which is equal to let's say it's 3 to the x plus 4. Let's say minus 2, for example. Okay, we want to graph this exponential function, this transformed exponential. So how are we going to do this? What we're first going to do is we're going to recognize what is kind of our basic exponential function, or maybe I'll call it our parent function. It's a common thing to use when we're talking about toolkit functions that have been transformed. So what I'll write over here is we'll think about the parent function. So our parent function is 3 to the x. This is the function that's being transformed. Now I want to know what has happened to 3x. Well, there's two things that have happened here. Notice that what we've done here is I've added 4 directly to the x value. I've added 4 to the x value. So what does this do? Well, remember, when we add something to our x values, the first thing to think about is this is going to be some sort of horizontal transformation. I'm affecting the x values. But when I add 4 to the x values, remember that shifts my graph to the left 4 units. So this is a shift left by 4 units. Okay, and what else has happened? Well, what I'm doing is I'm taking the exponential function. Once I plug a number in, I'm going to get out an output. I'm going to take those outputs and I'm going to subtract 2. So what this minus 2 does, maybe I'll move it over here. What this does is this shifts the graph down 2 units. So there are 2 transformations that are happening to 3 to the x. So what we want to do is we want to take the key features of 3 to the x. We want to physically move those key features to the left 4 units and down 2 units. So let me show you an organized way that I like to keep track of my work. Okay, so what we're going to do here is I'm going to go ahead and write 3 to the x right here. These are the key features of 3 to the x. So what are the key features of 3 to the x? Well, what's on 3 to the x? Well, we have if you plug in 0, you're going to get an output of 1. Okay, and if you plug in 1, you're going to get an output of 3. And 3 to the x also has a horizontal asymptote, horizontal line, y equals 0. Now what I want to do to these points is I want to shift them up 4 units. I want to shift them to the left 4 units and down 2 units. So I'm going to record those transformations over here. So what we need to do is I'll kind of just draw an arrow here. We need to shift the function left by 4 units, left 4 units. We also need to shift the graph down 2 units. Okay, so let's figure out how to do this. Now, it won't turn out that it won't matter what order you do these in. So think about it. If you have a point and you move it this way 4 units and down 2, that'd be the same as you moving it down 2 and to the left 4 units. So the order in which you do these will not matter. We'll talk about there are some transformations that we do need to be careful about order. Okay, so how are we going to do this? Well, when I'm physically moving a graph to the left 4 units, what am I doing? I'm affecting the x values. So what I want to do here to physically move a point to the left 4 units is I want to subtract 4 from all my x values. So I will take the point 0, 4 and I'm physically moving it to the left 4 units. So it will no longer be at the point 0, 1, it'll now be at the point -4, 1. Similarly, I'm going to take the point 1, 3 and I'm physically going to move it to the left 4 units. So I'm going to take the x value 1 and I'm going to subtract 4 units from it. So 1 minus 4 will get out a -3 and a 3. So now, what about the horizontal asymptote? Okay, well, let's think here. I have this horizontal asymptote. And what am I doing? And notice that, pretend my arms are going infinitely out. So I have this horizontal asymptote. It's infinitely long, and I'm physically moving it. I'm physically moving it to the left, running a room, to the left 4 units. Well, if I'm moving it to the left 4 units, it's still an infinitely long horizontal line. By shifting it left and right is not going to affect where the horizontal asymptote is. So the horizontal asymptote will not be affected, so I still get y equals 0. A great way to think about this is when I'm shifting it left 4 units, I'm affecting x values. Well, this says y. I'm not affecting y values. Okay, now what we're going to do is now I need to take these points and I need to move them down 2 units. So when I move, I'm going to take these points and I'm physically moving them down 2 units, and that's going to affect the y coordinates. So I'm going to want to take all the y coordinates and I'm going to subtract 2 from them. So now we'll have -4, 1, I'll take away 2, I'll be at -1. -3, okay, now I'm going to take 3 and I'm going to subtract 2, so I'm going to be left with 1. Now I have this horizontal asymptote and I'm shifting it down 2 units. So y will be equal to -2. That's where the new horizontal asymptote will be. So now, what we have on the bottom here, these are now going to be, I'm going to write here, these are going to be now kind of the key features of the function we want to graph. 3x plus 4 minus 2. Okay? So let's go ahead and graph this function. So let's do it right here. Wish I had a little bit more board space. So used to having 2 or 3 boards or just a really large board when we're on campus. Okay, our horizontal asymptote, we're going to shift it down 2 units. So here's 1, here's 2, -2. Here's our horizontal asymptote. Okay, we have the point -4, -1. So here's -4, here's -1. So this point will be on the graph. And -3, 1. So here's -3 and here's 1. Let's put our -3 right here. Let's put how about our -4 right here. So -3, 1, -3, 1. I'll bold these points in. So now what's going to happen is these 2 points here are going to guide us about how the graph is moving. Okay, so in this case here, the entire exponential function, when we're ever drawing these, will always be above the asymptote or below the asymptote. So since these 2 points are above the asymptote, the entire graph will be above this horizontal asymptote. So the graph is going to look like this. So let's graph it. So these points should guide you. These points should guide you to what the graph here will look like. Okay, so running a little, let's graph this in green. So here we have the graph of 3 to the x plus 4 minus 2. And there we have it. Here's the graph. Okay, let's go ahead and do another example. I'm going to go ahead and erase what we have here. So let's say that we want to graph the function. Let's say we want to graph, let's say, g of x. And let's say g of x is, how about we do 4? How about 4 times, let's do 2 to the negative x, 2 to the negative x, and then how about we subtract 3, for example. So let's go ahead and try to graph this exponential function. Okay, maybe pause the video and give this a shot on your own. Okay, let's do it together. Sorry for this kind of blue smeared all over the place. Hopefully we can see okay. Negative x. Okay. So let's first think about what our parent function is. Okay, so our parent function. Okay. Well, I hope you see that 2 to the x is the simplest exponential function we can get out of here. And what we're doing to 2 to the x is we're actually doing 3 different things to it. Okay, so the first thing to notice that we're doing to it is, well, let's notice that I'm multiplying the outside of the function. I'm multiplying the outside of the function by 4. So I'm taking the outputs of the function, I'm multiplying them by 4. This is going to vertically stretch the graph by a factor of 4. So here, I'm going to write vertical stretch by 4. Now, when I'm saying by 4, I mean by a factor of 4. I am going to be multiplying all my outputs by 4. What else has happened? Okay. Well, notice here that there's a negative here on the x values. So what's happening here? Okay. Well, I would have my normal 2 to the x, so I'd have my normal x values, and now I'm making my x values negative, so what that's going to do is, if my x values were positive, now they're negative, this is going to reflect the graph over the y-axis. So this negative here, I'm going to say I'm going to write just reflection. This is a reflection about the y-axis. Okay. What else has happened to the graph? If we're looking here at this negative 3, I'm subtracting 3 from the outside of the function. This is going to take all my outputs and they're going to shift them down 3 units. So this is going to be a shift down 3 units. So these are the 3 transformations that are happening to 2 to the x. So let's go ahead and make a table. Okay. So I'm gonna erase a little bit what we have here. Give ourselves a little bit of room. So we had a 4 times a 2 to the negative x minus 3. Okay? So we have our parent function. We have 2 to the x. Let's record its key features. If you plug in 0, you get an output of 1. If you plug in 1, you'll get an output of 2. And there's also the horizontal asymptote, y equals 0. So a good question we should ask ourselves is, does it matter which order we do those 3 transformations in? And yes, it does. So the way you want to think about it is order of operations, PEMDAS. Remember, we have to do multiplication and division before we do addition and subtraction. So when I'm looking at the transformations, this multiplying by 4, this vertically stretching it by a factor of 4, this is a multiplication style transformation. We need to make sure to do these ones first. Also, this negative on the x value, that's like a negative 1 times x. So the reflection is also a multiplication style of transformation. And now this shift, this moving down by 3, is like an addition or a subtraction style of transformation. We want to do those last. So you make sure you always want to do stretches and compressions and reflections first before you do any sort of shifts. Now, it actually doesn't matter which order you do the stretches and compressions or the reflections. You could do stretches and then reflections. You could do reflections and then stretches. Those don't matter. But what does matter is you make sure you do you do stretches and reflections before you do any sort of shifts. So order will matter. Just think of PEMDAS. Okay, so what is the 4 doing? The 4 doing, this is a vertical stretch. I'll put by 4, vertical stretch by 4. Okay. And then we also have the negative. This is a reflection. This is a reflection about the y-axis reflection. I'll put ref y-axis. Okay. And then we're also shifting the graph down 3 units. Okay. So I want to take these key features and I want to run them through the transformation. And once I'm at the bottom of our table, I now have the key features on the graph for the picture that we're trying to graph. Okay, so the first thing we're going to do is we're vertically going to stretch everything by a factor of 4. So when I'm vertically stretching, we're going to take all our outputs, all our y values, and multiply them by 4. So the new coordinates will be 0. I'll get 1 times 4, which will be 4. I'll have a 1. I'm going to take a 2, and I'm going to multiply it by 4, so I'll get out 8. Okay, and now I'm taking y equals 0, so I have this y equals 0, and all the features of the graph are going to get stretched, but this will not affect the horizontal asymptote. If you like, you can kind of think that we're taking 4 and multiplying it by 0, and we're still getting out 0. So the horizontal asymptote will not be affected by a vertical stretch. Now what we're going to do is now we're going to reflect these over the y-axis. So we're going to reflect these over the y-axis. What is that doing? So don't let this word y-axis confuse you. When I'm reflecting over the y-axis, this is not affecting my y values. It affects the x values. I do this every single time. I'm reflecting over the y-axis. This is affecting my x values. This affects my x values. So what do we want to do? We want to take all our x values and make them negative. So here I have a 0, so now I'll have a negative 0 and a 4. Well, I hope you believe that negative 0 is the same thing as 0, so this point will be unchanged. So this point will still be at 0, 4, and that should kind of make sense. I mean, if this is our axis right here, and we have the point 0, 4, and I'm reflecting over this line, well, this point is going to stay where it's at when I reflect over the y-axis. Okay, and we are now going to have, we had the point 1, 8, so now we'll have the point negative 1, 8. And again, if you think about this horizontal asymptote y equals 0 and I reflect it over the y-axis, well, that's still the same line. It's still the same exact line. So this will be unchanged. So we'll still have y equals 0. Okay. Now we want to shift the graph down 3 units, so I'm going to subtract 3 from all of my y-coordinates. So we'll now have a 0. 4 minus 3 is a 1. Okay, a negative 1. We have an 8, and we're moving it down 3 units, so now we'll be at negative 1 and 5. And the horizontal asymptote will be shifted down 3 units. So now we'll be at y equals negative 3. And now we can piece the graph together. So for this 1, 0, 1 going back to 0, 1, this is not something that always happens. It's just a coincidence, I guess, with the numbers that I chose. Okay, so let's draw a loose sketch of this. Let's draw a loose sketch. Running out of good black markers. Okay, so we have our horizontal asymptote at y equals negative 3. Here's negative 3, and here's our horizontal asymptote. I'll write a negative 3 right here. So here's our horizontal asymptote. We have the point 0 and 1, so 0 and 1 is on the graph. And we also have the point negative 1 and 5. So if I go back negative, I need to go up 5. So 1, 2, 3, 4, 5. So negative 1 and 5 is on the graph. Okay, so now what we want to do is we want to connect the points here. Now the graph of exponentials will either always be above or they'll always be below the horizontal asymptote. And so if I'm going from left to right and connecting the points, the graph, let's kind of do it like this. The graph will look like this. So here we have it. This is the graph. of 4 times 2 to the negative x minus 3. This is the graph. Okay, let's do another example. Looks like I need to do a good clean of the whiteboard, get the blue smeared all over the place. Okay, let's say we have the function, let's say it's h of x, and let's say this one is equal to, how about a negative? And let's do a 1/3. Let's do a 1/3 to the x. Let's do x plus, let's say x plus 4. Okay. Go ahead and pause the video and give this one here a shot. Okay, let's go ahead and do this. So the first thing we're going to do is we're going to recognize the parent function, or the parent exponential. In this case here, I hope you believe that 1/3 to the x is the 1/3 to the x is our parent function, or our parent exponential. This is the thing that is being transformed. In this case, there are two transformations we'll want to keep track of. Okay, the first thing we should keep track of is this minus out front. So what is this going to do? Okay, I have all the outputs of my function, and now I'm multiplying them by a negative. Here I have our outputs. I'm multiplying them by a negative. This will reflect the graph over the x-axis. So this is a reflection about the x-axis. Okay. The other transformation that's happening is this plus 4. Now here I'm adding 4 directly to the x value, so that's going to shift my graph left 4 units. So this will be a shift left 4 units. If it was x minus 4, we should be shifting it to the right 4 units. So these are the two transformations that are happening. Okay, so let's go ahead and sketch this. Or let's record all our points. So we have our function 1/3 to the x. Okay. Let's write the key features of this one. Well, if you plug in 0, you're still going to get an output of 1. Okay. If we plug in 1, we'll get an output of 1/3. Okay. And what else will we get? We have our horizontal asymptote y equals 0. Okay, let's record our transformations. So in general, we need to make sure that we do reflections and stretches before we do shifts. So the first thing we're going to do is let's do a reflection about the x-axis. Reflection about the x-axis. And then we are going to shift left 4 units. We're going to shift left 4 units. Okay, let's do it. Okay, so when we're reflecting over the x-axis, so we need to think, don't be confused, this does not affect the x values. When I'm reflecting over the x-axis, this affects my y values. So I'm going to take all my y values and I'm going to make them negative. So here we'll have a 0 and a -1, and we'll have a 1 and a -1/3, and the horizontal asymptote will stay where it's at. Okay, now we're going to move the graph to the left 4 units. So I'll subtract 4 from the x values, so -4 and -1. And we'll have what, a -3 and a -1/3. And this will stay the same. We'll still be at y equals 0. Okay, let's go ahead and sketch this. Let's go ahead and sketch it. Okay, we have our horizontal asymptote at the x-axis. Here's our horizontal asymptote. Okay, we're at the point -4, -1. So here's -4, here's -1, so we have this point. And we also have the point, maybe I'll move this -1 down a little further, because I got a -1/3. Okay, so maybe I'll put -1 right here. So here's -1, -4, -1 is right here. And we also have the point -3 and -1/3. Let's say -1/3 is roughly right here. So now we have everything we need to sketch this. So notice that since these 2 points are below the horizontal asymptote, the whole graph is going to be below the horizontal asymptote. And moving from left to right, the graph will look like this. So here's the graph. Here's the graph of -1/3 to the x plus 4. Okay. Let's do one more example. And for this next example, I'm going to do it in 2 different ways, just to kind of give you a tip. So let's say, for example, that we want to sketch the function, let's call it f of x. And let's say it's going to be 4. Let's say it's 3 times a 1/2 to the x. For fun, how about we subtract 1, and how about we subtract, I don't know, 5, let's say. Okay. I'm going to give you 2 different ways to approach this problem. Okay, so go ahead and pause the video and try this on your own first. The first way I'm going to tackle this problem is I'm not going to touch it at all. I'm going to leave it how it is, and I'm going to recognize that 1/2 to the x is our parent function. Okay, and let's see what's happened to the function. Okay, notice I'm multiplying the outside of the function by 3. I'm just going to record them over here. So we're going to have a vertical stretch by a factor of 3. Okay. I'm subtracting 1 from the x value, so this is going to shift my graph to the right 1 unit. And we're subtracting 5. So what's going to happen here is we're going to be shifting the graph down 5 units. Okay. So let's go ahead and run the key features through the transformation. So 1/3 to the x. Okay, the key features we have on this one is we have 0, 1. We have a 1 and a 1/3. And we have the horizontal line, y equals 0. Okay, we have to do stretches and compressions and reflections before we do shifts. So let's do a vertical stretch by 3. And then we're going to shift it left by 1, and then down by 5. Now you could have done these in either order, and it wouldn't have made a difference as long as you're doing your vertical stretch first. Okay. So when I'm vertically stretching, what I'm going to do is I'm going to take this is a 1/2. 1/2. This is a 1/2. Okay. Okay. So now when I'm vertically stretching by a factor of 3, I'm going to take all my outputs and I'm going to multiply them by 3. So in this case, what we're going to have is we're going to get a 0 and a 3. We'll get a 1 and a 3 times a 1/2. That'll be a 3/2. And if I multiply 0 by 3, I still get 0. So I'll still get y equals 0 here. Okay, now I'm going to want to shift the graph to the right by 1 unit. So I'm going to add 1 to all the x components. So I'll get a 1 and a 3. I'll get a 2 and a 3/2, and I'll get a y equals 0. This is affecting the x value, so if you want to think about it, it's not affecting the y, or think about this infinitely long horizontal line, and I'm shifting it to the right a unit, it's still an infinitely long horizontal line. And now we're going to shift all these points down by 5 units, and this is where this problem can kind of be a little bit of a pain. Now when I'm shifting down 5 units, Okay, I'm going to get a 1. A 3 minus 5, we get a negative 2. What's kind of annoying here is now I got to deal with fractions, which is unfriendly. So I got to say, okay, I got 3 halves. I got to subtract 5. So 3 halves. 5 is the same thing as what? 10 halves. So 3 minus 10, this is negative 7 halves. So now we have a 2 and a negative 7 halves. And now I'm going to shift this down 5 units. So our new horizontal asymptote will be at y equals negative 5. Okay. So now let's go ahead and graph this. So let's see, our horizontal asymptote will be at negative 5. Or it'll be the horizontal line y equals negative 5. Okay, so here's our, this black marker is gone. Okay. This green marker is not too much better. Let's see if I can get something a little bit nicer to work with. So here's our horizontal asymptote. Okay. We have the point 1 and negative 2. So here is 1 and here is negative 2. So here's 1, here's negative 2. So 1 and negative 2. This will be on the graph. And 2. So 2 and negative 7 halves. I hope you believe that negative 7 halves is the same thing as negative 3.5. So over 2, I need to go down, negative 3.5. Here's negative 3, here's negative 4. So negative 3.5 will be right here. So 2 and negative 7 halves. So looks close enough. Okay, now we'll connect these points here. Now remember, since it's above the asymptote, it'll stay above the asymptote. So this will be the graph of 3 times 1/2 to the x minus 1 minus 5. Here's the graph. This is one possible way you could have done this graph. Okay, however, I'd like to, just for fun, suggest a different way we could have done this. So let's do that now. So a different way we could have done this problem is we could have remembered that 1/2 is the same thing as 2 to the negative 1. So we could have rewritten this function. So let's kind of record this over here. 1/2 is equivalent to 2 to the negative 1. So we could have written this 1/2 as 2 to the negative 1. And remember that property of exponents, that if you have, I don't know, if you have a number b raised to the n raised to the m, this is the same thing as b to the n times m. So this is going to be equivalent to 3 times 2 to the negative x minus 1 minus 5. So we just need to make sure that we introduce parentheses when we multiply the negative 1 and the x minus 1. So I'm going to go ahead and write that up here. So we could have seen this as 3 times a 2 to the negative x minus 1. It's a different way to see this. So now what's nice is now what our parent function here will be. Our parent function will be 2 to the x now instead, rather than 1/2 to the x. Okay? So now what we want to do is we want to record the transformations. Now, I want to make a note here that we need to be super careful with parentheses. When we have a 2 to the negative x minus 1, okay, the question you might have is, if I were to distribute in this minus sign, does this affect the shift? The answer is no. So basically what I'm saying here is when you have a 2 and you have a negative x plus 1, so these are equivalent. Now when you're reading transformations, you got to be careful with which version you're looking at here. Okay, so this negative out front for both of them, I am having the negative affect the x's. So this will still be a reflection over the y-axis. This will still be a reflection over the y-axis. y-axis. But it looks like in this version here, since I'm subtracting 1 from the x, here it looks like I'm shifting it to the right 1 unit. But here you might be tempted to think that I'm shifting it to the left. I'm shifting it to the left 1 unit. So which version is right? The upper version is right. So in this case here, what we're actually doing is we're still shifting right by 1 unit. We're still shifting right by 1 unit. Okay, so what we have to be careful of is when I'm trying to figure out my shifts, I have to know what's acting directly on my x. So here with the parentheses, I can see a -1 is acting directly on my x. I'm subtracting 1 directly from my x, so that's shifting me to the right 1 unit. Over here, I'm adding 1 not to x, but I'm adding 1 to a -x. So I can't quite read the horizontal transformation here. I would need to make sure to factor out that x so I can see what's exactly acting on the x to know the true shift. So just be a little bit careful. Okay, so what's going on here? So let's record. So we have our function 2 to the x. Okay, the key features on 2 to the x will be what? If you plug in 0, you get out 1. If you plug in 1, you get out 2. Okay, it still has the horizontal asymptote y equals 0. Okay, let's record our transformations. So there was a cost for what we did here. I'll talk about it in a second. So instead of having a nice a fraction here like we had in the last example, we kind of traded that. We traded that fraction for an extra transformation. So we could first have our vertical stretch by 3. Okay, it's the first thing we'll do. Okay, and then we also have this new negative here gives us a reflection. This is a reflection about the y-axis. Now you could have done these in either order, wouldn't matter, as long as you do vertical stretches and reflections first. So you could have reflected over the y-axis and then vertically stretched by 3. Okay, and then what else is going to happen? Okay, we're going to go right 1 unit. So we're going to go right 1 unit. We're going to go right 1 unit. And we're going to go down. We're going to go down 5 units. Okay. So our vertical stretch, okay, we're now going to have a 0 and a 3. Now I'll have a 1 and a 6. Okay, and the vertical stretch won't affect the horizontal asymptote. Okay, now we're going to reflect over the y-axis. Reflecting over the y-axis changes our x values. It makes our x values negative. -0 is the same thing as 0. Okay, so now we'll get a -1 and a 6, and we'll still have y equals 0. We're going to shift it to the right 1 unit, so now we have 1, 3. We'll have 0, 6. And we'll still have y equals 0. And now we're going to shift down 5 units, so we'll subtract 5 from our y value, so we'll get a 1 and a -2. We'll get a 0 and a 1, and we'll have a y is equal to -5 when I shift that horizontal asymptote down 5 units. Okay? So now we just have a different set of points to plot, but the graph should be the same as the one we did the first way we did this problem. So if we're sketching this, do a nice loose sketch. Okay. Here's -5. Here's our horizontal asymptote. Okay, we have the point 1, -2. So here is 1, and here's -2, 1, -2. And we also have the point 0 and 1, so 0 and 1. And now, what we can do is now we can go ahead and draw the graph. And here it is. Okay, and this should be the same exact picture. We have different points that we're plotting, but this should be the same exact picture as the one we did in the last example. Okay, that's all I have for us on graphing transformations of exponential functions. What we're going to be doing in the next video is we're going to start doing an application of exponential functions. We're going to be talking about we're going to be talking about what's called compound interest. We're going to learn how money grows in your bank account. We'll see you there. Take care.